Welcome back. I hope everyone's having a good day so far. We're going to start chapter 3 today, and we won't quite finish it. But the title of the chapter is Demand for Health, the Grossman Model. To help you appreciate this chapter a little more, I'm going to give you a quick catch-up in terms of what a model is. Basically, models are very similar to maps. Okay, what is a map good for? A map is good for clarifying a route between 2 points. And what you include in maps are major things that you need to understand the route. So for example, highways are included on maps. But importantly, things like stop signs are not included on maps. And maps intentionally omit particular realities about the world, because if we included all the details about the real world in a map, then it would just be really difficult to understand what we're trying to understand, and that is the path between 2 points. The exact same idea is true of models. In models, economists want to know something, but the problem is that the world is really complicated and it has a lot of details. And those details really muddy our understanding of how things in the world work. So what we do is we build a model or a mathematical framework that intentionally includes highways or the things that we think are important for understanding what we're interested in. And then the models intentionally exclude particular realities about the world. And the reason they do that is so that we can have a clear understanding of the path or the thing that we're interested in. In today's chapter, we're going to look at a model that an economist named Grossman built. And the purpose of Grossman's model was to help us understand how people make decisions about how much health to demand. Okay, recall from chapter number 1 that health is unusual. And one way that health is unusual is that health happens to us and we choose it. And what we choose impacts the probability of what happens to us. So in other words, some days I wake up and I just happen to be sick. So health, or sickness more precisely, just kind of happened to me. But I can also make choices such as how much I exercise that influence the probability that I'll get sick or stay healthy. Notably, however, every choice that I make involves an opportunity cost. If I choose to go to the gym for 2 hours every day, then I'm implicitly choosing not to go to work during those 2 hours and make money that I could be spending on vitamins. So there are all these complicated trade-offs that are always happening behind the scenes when we're making choices about our health. And so the Grossman model tries to provide a framework for explaining how choosing one health input over another will affect your health. To begin with, I'm going to explain the setup of the model today. There's a lot of notation that looks scary. Don't get scared. I'm going to try to walk you through it. It's actually fairly simple. So just listen along carefully and things will start to settle in as you just get exposure to it. First of all, the model has one goal, and the goal of the Grossman model is to maximize a person's utility. Okay, what is utility? Utility is basically happiness. So if I have more utility, then that just reflects the fact that I have more happiness. So what the solver of the Grossman model wants to do is maximize, in this case, single period utility. In the model, utility is a function of 2 variables, and those variables are h and z. All right, one note on notation. Throughout this chapter, you're going to see a lot of functions. In terms of notation, functions look like a letter that equals that same letter with a parentheses and then stuff inside the parentheses. The letter is kind of like the destination on the map. It is where we're trying to go effectively. And the stuff inside the parentheses is kind of like the highways. It's the options that you have for how to get to the destination. So here we want to increase utility. And so if we're going to increase or decrease utility, then we have to do it through the channel of H or through the channel of Z. There are absolutely no other ways that we can influence utility in this model because we only have these 2 highways to drive on. Okay, because H and Z are the only 2 things that we can vary or we can increase or decrease as a way to affect utility, we call these variables. Okay, what are H and what are Z? H is going to stand for a person's level of health. Z is going to stand for something that we call a home good. A home good is kind of like a composite good that represents everything else that a person can consume outside of health. So they can have health in their life, and then they can have other stuff in their life, and all the other stuff is going to go into the category of home good. Okay, note that there are subscripts on the letters. The subscript, little t, is going to index the particular time period that we're considering. So in this case, the U and the H and the Z all have the exact same subscript T. That means we're looking at the level of utility and health and home good and the same time period T. In other words, your level of utility in time period T is going to be tied to your level of health in time period T and your level of home good in time period T. Okay, so if a person wants to increase their utility, either they're going to have to produce more health or they're going to have to produce more home good. So how does a person go about producing health or producing home good? First, to understand the production of health, we're going to look at the health function. Here, health is a function of 3 variables. And the way you can see that is because there are 3 things inside the parentheses. So if I want to increase health, or H, then I have to do it by running along one of 3 highways, or in other words, varying one of 3 variables. The first variable is H subscript T minus 1. Okay, if T denotes a particular time period, then T minus 1 means I take the time period T and I go back 1 time period. So another way of thinking of H subscript T minus 1 is a person's level of health yesterday. So in other words, yesterday's health influences HT, or today's health. The second variable is T subscript T superscript H. Big T is going to stand for time. The subscript little t again denotes the time period we're looking at, and the superscript H is going to stand for what I'm spending my time doing. Again, H represents health, so big T subscript little t superscript H is the same thing as the time that I spend today doing health-related things. So if I spend 1 hour today at the gym, that would be an example of TTH, and that's going to affect my HT, the thing on the left of the equation, which is my health today. Okay, one last variable that can influence a person's level of health is M subscript T. M is going to include all market inputs into health. So anything that you can go to the store and buy that influences your health is going to be an example of M. And so, according to the function, health-related products that you buy in this time period T are going to affect your health in this time period T. So to give you some examples of these variables, if I spend 1 hour today running, that's going to be an example of TTH. Example number 2, if I go to the store and buy 1 bottle of vitamins today, that's a market good that is health-related, so that would be an example of MT. Another example, if I had the flu yesterday, that would be an example of H subscript T minus 1. Okay, so again, the person is trying to maximize their utility. One way utility can be increased is through increasing health, and there are 3 variables that affect your health. Your health yesterday, the time today you spend doing health-related things, and third, the number of market inputs that you buy today that affect your health. Okay, now a person can also increase their utility, which is what the whole model is trying to do, by producing more home good. So if a person wants more home good, how would they go about producing it? Well, home good is a function of 2 variables, and those variables are big T, subscript, little t, superscript Z. And if you're kind of following the pattern, it should be easy to figure out what this means. This variable is going to be the time that I spend today doing home good things. Or another way you can think of this variable is the time that I spend today playing. It's like the number of hours that I spend in this time period just doing fun stuff. So if I spend 2 hours at the movies today, then that's going to be an example of TTZ. The other variable that can influence a person's level of home good is going to be J subscript T. J is going to be all the market inputs that go into home good. So anything that you can go to the store and buy with money that influences your home good, that's going to be an example of J. So if I go to the store and I buy a set of dominoes, that's just a fun market product that impacts my home good, so it would be an example of J. All right, just to recap, the overall goal of the Grossen model is to make a person as happy as possible. In other words, we want to maximize their utility. And if we're going to affect utility, we have to do it either through increasing health or increasing home good. And if I want to increase health, then either I have to do that through being healthier yesterday, spending time today on my health, or going to the store and buying things that increase my health today. On the other hand, if I want to increase my utility by increasing my Z, or my home good, then the only way I can get more home good is if I spend more time on fun things today, or if I go to the store and I buy things that are fun. So I buy home good things today. Real quickly, let's go back to the analogy of the map. Just as a good map should include realities about the world that are important, a good model needs to include realities about the world that are important. And one reality of the world that's super important is that people have a limited amount of time. So what you might say conceptually is, well, if time at the movies gives a person more home good, and more home good makes a person happy, and we're trying to just maximize happiness, then why not just spend millions of hours at the movies? And the reason we can't do that is because there aren't millions of hours that exist. There are only 24 hours in a day. So we're going to impose a constraint that says there's a limited number of hours, and people have to distribute their hours across a set of activities. Just for simplicity, let's assume the time period we're considering is 1 day. And for brevity, I'm going to suppress the subscript T's on the screen, but you can assume that they're there and there's no loss of generality. Theta is going to represent the number of units that are available in a given time period T. So since we're thinking about 1 day, theta would be 24 hours. Those 24 hours need to equal the summation of the time that you spend on 4 activities. The first activity that you could participate in is you could work. So big T, superscript W, is just the number of hours you spend working within the 24 hours. Another activity you could participate in is playing. So big T, superscript Z, is going to be the number of hours you spend playing every day. You could also spend your time doing things that are intended to increase your health. So we're going to call this big T, superscript H. Again, this would be like the number of hours per day that you spend at the gym. And then the last thing that you could spend your time doing is being sick. So we're going to call this big T, superscript S. And the idea is that you have to spend your time each day doing 1 of 4 activities, and when you add up the time you spend on each activity each day, then it has to sum to exactly 24 hours. In other words, theta equals 24, so 24 needs to equal the sum of the hours you spend working, plus the hours you spend playing, plus the hours you spend doing health improving activities, plus the time you spend being sick. One thing to just mentally highlight in your mind about the time constraint is that one of the activities is just not like the other. And the activity that's different is the time that you spend being sick. And the reason sick time is unique is because TS is clearly not productive time. We can define productive time, which we're going to call big T superscript P, as all the time of the day minus the time you spend being sick, which is not productive. One note in terms of notation again, if you see an equal sign that has 3 bars, what that means is that we're creating something new and we're defining what it is. So in this case, we're creating a new thing called productive time, and we're going to say we define it as the hours in the day minus sick time. So whatever time is left over in the day after you strip out your sick time, that's what we're going to call productive time. So what is theta minus TS? Well, if you look at the original theta equation, it has 4 big T's in it. If you subtract from those 4 big T's the TS, then what's left over is the time working plus the time playing plus the time doing health-related activities. So that's effectively the summation of those three things gives you productive time. So to summarize, that's the first constraint. We're going to call it the time constraint because it acknowledges the fact that in life we have a limited number of hours, and in this model we can only spend those hours on one of four activities. Okay, the second constraint that we're going to incorporate into the model is the reality that people do not have infinite amounts of money to spend, and we're going to call this the budget constraint. The budget constraint tells us that a person's income today, or Y subscript T, is going to be exactly equal to their wage rate per hour, or little w, multiplied by the time they spend today working. So again, this should be completely intuitive, although the math looks kind of scary. Simply put, the money that I have in the bank is equal to my hourly wage rate times the number of hours I work. Okay, we're going to say in this simplified version of the world that people can spend their income Y on one of two things. The first thing they can buy is M. Again, to jog your memory, M is all the market inputs that go into producing health. And we're also going to say that the price of each unit of M is P subscript M. So very uncreatively, we're just saying that the price of one M is PM. Okay, the second thing that a person can buy is J. Again, to jog your memory, J is all the market inputs that go into home good. And again, very uncreatively, we're just going to say that the price of one unit of J is going to be P subscript J. One assumption that we're going to make is that a person gets no utility from money sitting in the bank. So in other words, if they've got $500 to spend and their goal is to maximize their utility, then it's going to make all the sense in the world for them just to blow the $500 and spend it on something that either gets them more health or more home good. So in this case, what we're going to say mathematically is that a person's Y will just inevitably be equal to the money that they spend, and the money that they spend is going to be the price of each unit of M times the number of M's that they buy, plus the price of each unit of J times the number of units of J that they buy. Okay, so this is almost the end of the notation. There are three conceptual things I want to highlight, and then we'll break for questions. One reason the Grossman model is interesting is because health plays three roles in this model. First of all, health in this model is a consumption good, and the way we see this is that health directly gives higher utility. So if you glance back up to the utility function, a variable in the utility function is H. That means that if you give a person more H, that just directly increases their utility or their happiness level. So health is just valuable in and of itself because people get utility out of just having it. The second role of health in the Grossman model is that health is an input into production. In other words, it generates productive time. So if you look at the equation for productive time, then if a person has no health, then their sick time is going to be 24 hours. And that means that there's no hours left in the day for the person to work or for the person to play or for the person to do health improving activities. In other words, if they're not healthy at all and 24 hours are being spent sick, then they have no capacity to produce any H or any Z. So you need health to produce H and to produce C. Note that this particular role of health is distinct from things that we often think about like widgets. In the case of widgets, you don't need widgets to consume more widgets. But in the case of health, we need health in order to produce more health and home good. So this makes health unique from other goods that we typically look at in standard markets. Finally, health is a form of capital, and the way you can think about capital is that capital is something that carries over from one time period to the next. And if you look at the subscripts in the Grossman model, they're always T, little t, with the exception of T minus 1 showing up on one of the health variables. So in other words, health carries over from one time period to the next. That means health today affects health tomorrow. All right, that's the end of my somewhat technical spiel for the day. If you have any questions about the notation, submit those questions during the question break. Today's class is just a setup of the model so that you can understand what all the components are. And after we have 10 minutes of questions, I will resume the lecture for the exercise period. Today's exercise is hopefully going to be pretty simple. What I want you to practice thinking about is how real things in the world fit into the Grossman model. And specifically, I want you to look at two functions in the Grossman model and one constraint. The two functions that I want you to have in mind are the health function and the home good function. Health is a function of three variables. It's your health yesterday, the time today that you spend doing health improving activities, and the market inputs that you buy to improve your health. Home good is going to be a function of two variables. It's going to be the time that you spend today playing and market inputs that go into home good. The constraint that I want you to particularly have in the forefront of your mind is the time constraint. The hours in a day, theta, have to be spread out between one of four activities. So you can spend time working, you can spend time playing, you can spend time doing health improving activities, or you can spend time being sick. Okay, what I'm going to do is I'm going to give you 5 items, and for each item I want you to indicate where it shows up within either the function that I noted or the time constraint. So I'll give you an example just to kind of get the gears turning. So if I gave you the example of a Monopoly game, then where does the Monopoly game kind of fit into the model? Well, a Monopoly game is a market good. It doesn't help your health at all. It's just a fun thing. So a Monopoly game would be an example of J subscript T. So for each of these 5 items, I just want you to identify which of the 5 red things that I have on the screen the item that I give you is an example of. Okay, item number 1 is 2 hours spent playing baseball for exercise. Item number 2 is a baseball game ticket. Item number 3 is 1 hour spent watching a baseball game for recreation. So you're just a spectator, just enjoying the game. Item number 4 is a treadmill. And item number 5 is gummy vitamins. So make sure you submit 5 responses for this exercise, and then you'll be free for the rest of the day.